me start with the system level decision we made, which is kind of unique. It's typically uncommon to find jumbo frame support in acceleration devices. And when I say jumbo frames, I mean packets larger than 1500 bytes. The reason why is that it makes life difficult for deloop engines when you have very large packets. It makes life difficult for your TCP segments, etc. when you have large packets. We designed our box to be able to support large packets. And when I say large, I mean FCIP packets. So if for all the stored networking engineers watching this, you know that an FCIP packet, especially on an MDS, is much larger than 1500 bytes. Cisco advises that you set your MTU to 3000 bytes, or if you want to be very kind of accurate about this, you can set it to 2300 bytes. That's a larger packet than what you would expect on the internet, for an example. What we made sure we can do on our box is support large packets. So if you do have 2300 byte MTUs in your network, no problem. We will take that large packet, we will do the right thing with it, and we'll pass it on with packet boundaries intact. And that's the next big thing. When you talk about classic TCP/IP applications, there is no sense for what a packet is. TCP, as you know, is a segment-based protocol. So it can span multiple packets, and within the path on the WAN, you can change the number of packets being sent out. That's okay. The receiver does not really care how many packets there are. They care about the segment. But that is actually not the case with FCIP traffic. FCIP happens to use TCP more like a tunnel than a transport protocol. So when FCIP sends a packet, it expects that exact packet with that same size to be delivered to the other side. This is a very hard thing to do for the existing acceleration solutions or optimization solutions. Not so with us. We made sure that our implementation, it works at a packet level. So the number of packets you send, the sizes of those packets, the number and sizes, they are maintained across the WAN. So on the other side, you get the packet as is exactly, so that your FCIP traffic is not, it doesn't break. And that is what happens today. So in many cases, you don't find any acceleration going on for FCIP because those acceleration devices break FCIP traffic. Not the case with us. We can carry out any acceleration for FCIP. We can support large packets, if you like. And we maintain packet boundaries, which is critical for FCIP to continue doing its functions. There's a third thing which is very important. In classic applications, they are designed to understand that when TCP starts its functions, it starts slow and then it kind of, it picks up steam and goes on. When you're doing a replication, there is no such semblance of understanding of TCP. If I have packets, or rather if I have blocks to replicate, I'm going to send those blocks. I don't really care if TCP is doing slow start or not. I'm going to send those blocks. So the acceleration devices, they better be ready to receive anything from a few hundred kilobits to a gigabit instantaneously. An array can send you any rate up to a gigabit like this. Are you ready to accept that? And actually, more importantly, can you even support a TCP connection at a gigabit a second? There is no such thing in the market today. There is nothing that can support that fast of a TCP connection, proxy TCP connection. We can. You can run up to a gigabit per connection. No problem. We will proxy it. We will make sure the packet boundaries are maintained. And of course, if you, like I said, if you are using jumbo frames, no problem. We'll continue to maintain that too.